We're going to talk about a very famous Big Al scientist named Alfred Wegener, although it starts with a W, Big Al. We say it Wegener because I believe he was German. And how his idea of continental drift became what we have today as the theory of plate tectonics.
So what was Wegener trying to do? Well, he was trying to figure out why we have land features where we have them on planet Earth. He came up with this whole hypothesis called continental drift, which is basically saying the continents are drifting around on top of the Earth and have, as they move, collide, separate, etc., they create all these landform features that we see, mountain ranges and valleys and volcanoes, etc. So what were his lines of evidence? Well, here they are.
So he had four things that he was able to use to help support his theory. And we have the page numbers here. Those would be good to jot down. First was the fit of the continents. So they have Pangaea. Some of you have heard of that before, the huge continent when they were all together. There's a whole bunch of names for the different ones throughout history. And you can see that on page 77. But they actually fit together like puzzle pieces. If you look at Africa and South America, that's what they're talking about. The second one, similar fossil records on different continents. So you're going to find the same species recorded in the rock, although now there's a giant ocean between them. The third one, same rock formations on different continents. There's literally identical rocks that are separated by an ocean. They were at one time connected. And then four, evidence of similar past climates on different continents. We'll go into a little bit more detail about that one in a little bit.
All right. So detail, as you can see here, I mean, this is kind of what Earth looks like today. And if we were to go and put all the puzzle pieces together, oh my goodness, all the continents would kind of fit. And this is kind of the first thing. The continents fit like puzzle pieces, which is what Wegener said, oh, maybe they were together. And, since Pangea or Pangaea, which about 225 million years ago, you can see over time how the continents have moved towards their present place, of which if we're going to hang out for a few more million years, we'd notice that change. Fossil evidence. I mean, how do we get these land-dwelling fossils to end up on two continents that are separated by big chunks of water? Well, maybe if they were together, the animals could freely roam. Or the same for this one right here, which is a tree plant, or this land animal, etc. But if the continents were all together at one time, it would be easy for plants and animals to move back and forth between continents because they would be one giant landmass. Fossil evidence. Another view of fossil evidence where they are today, and you can kind of match up and always pause this to show where different fossils are on different continents separated by huge chunks of water. Pretty crazy. He did a good job coming up with that. The rock formations. The rocks on the Appalachians in North Africa and part of England, Greenland, and Norway are all the exact same. The rock layers, as we learned in our last unit, superposition, all work great. They're the same age, the same layer on top of each other. How could they have formed at the same time in the same succession? Maybe they were forming next to each other. And then past climates. At one time, the whole area in white was under a glacier, ice, basically. And that's really weird because look at where India is today, to have ice way across the equator and way below the equator all at the same time. Crazy. So these were the main four lines of evidence that Wegener had, and he was laughed at.
Yep.
Pretty bad. People said he was a nut, you're crazy, this will never come. How can we really prove these? What the hypothesis of continental drift was trying to answer, and who was the main creator of that. I mean, that's not that bad. You can always review this. Make learning fun. Bye.
Big Al.